Hello, you're welcome to the chemistry series with Excellence Simplified, and today we are going to be looking at the periodic table. Now, the periodic table is a chart that organizes all the known elements based on their atomic numbers, chemical properties, and electronic configuration. Now, there are 118 known elements. 118 known elements. Now, the periodic table tries to organize these known elements based on their atomic number, based on their chemical properties, and based on their electronic configurations. Now, the early periodic table, the first version of the periodic table was produced by Mendeleev. So it's called Mendeleev periodic table. Now check the spelling very well. In 1869, Dmitry Mendeleev created the first version of the periodic table. And you should take note that his own version, Mendeleev version of the periodic table, he arranged the elements based on their relative atomic mass. And one thing he did was he created this periodic table, and his periodic table, there were gaps because he arranged only, I think, about 60 something elements, and he left gaps for elements that were not yet discovered at that time. That based on their properties, he predicted that there is an element that should fit in here that has not yet been discovered. Now, take note that he arranged it based on relative atomic mass. But in 1913, Henry Moseley, which is the person that produced the modern periodic table we are using now, Henry Moseley improved Mendeleev periodic table by arranging elements by atomic numbers. Please take note. The modern periodic table arrange elements based on their atomic numbers and not relative atomic mass again. Mendeleev arranged it based on relative atomic mass, but Henry Moseley arranged it based on their atomic numbers. Now, this arrangement of elements based on their atomic numbers led to the proposition of the periodic law. Now, the periodic law states that when elements are arranged in order of increasing atomic numbers, their physical and chemical properties recur periodically. Arrangement of the physical and chemical properties of elements is as a periodic function of the atomic number. That is another way you can put it. Now let me explain that. The periodic law is saying that if you arrange elements based on their increasing atomic number 1, 2, 3, 4, 5, 6, that you observe a trend that their physical or chemical properties recur periodically. So they discovered that when they arrange elements from, say, group, okay, let's take it bit by bit. So when I explain the groups and the period of the periodic table, you are going to understand better. I'm going to clean this board after I explain all this, and we are going to draw the periodic table and we demystify it, simplify it. All right, so that's the periodic law. Now let's look at the structure of the periodic table. The periodic table has periods and groups. So the periodic table has periods which are horizontal columns, horizontal like this, and it has groups which are horizontal rows like this, and vertical columns. So the groups are vertical. So here we can have, if groups are vertical columns, then this can be group 1, group 2. I'm using, for example, group 3, group 4. While the horizontal rows represents our period. So we can have period 1 here, period 2, period 3, just like that. So let's take the periods and the groups individually before we draw the periodic table, and we look at them in details. Now, periods. There are 7 periods in the periodic table. There are 7 periods. So there are 7 horizontal rows in the periodic table. Now, each period shows elements with the same number of shares. Now, please, I want you to listen very well here. Now, for you to place elements in the same period, they must have the same number of shares. What does that mean? Let me take 2 elements. let's take something like, let's take sodium and aluminum. Let's just look at these two elements. Sodium, what's the atomic number of sodium? Sodium is 11, right? What's the atomic number of aluminum? 13, right? Good. Now, let's try to draw the shell configuration. Please, in our last video, I taught how to draw shell configuration and electronic configuration. I taught that. So if you missed that video, go back to that video and watch after this. Now, if you are drawing the shell configuration of sodium, you'll be having 1, 2. Remember that the K shell only holds 2. 3, 4, 5, 6, 7, 8, 9, 10. Remember that the L shell, which is the second shell, holds 8. Then the next one, 1. If you count it now, this is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is for sodium. If you are drawing for aluminum, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Now, this is for aluminum and this is for sodium. If you count the number of shells, how many shells do we have here? This is 1, 2, 3. So sodium has 3 shells. If you look at aluminum, aluminum has 1, 2, 3. It means aluminum has 3 shells also. Now, since they have the same number of shells, you have to place them in the same period. So what determines elements you place in the same period is the number of what? Shells. So since this one have 3 shells, this should be in period what? Period 3. This one should also be in period 3 because they have 3 shells. What of elements like, let's say, elements like oxygen? Oxygen, what's the atomic number of oxygen? Please, if you don't know the first 20 elements, I did a video on that and I gave acronym to remember that he has little brain but cannot offer. Oxygen is 8, Abi? Alright. Now if you are drawing the shell configuration of oxygen, this will be 1, 2, 3, 4, 5, 6, 7, 8. How many shells do we have in oxygen? 2. So oxygen should be in period what? Period 2. So take note that period shows elements with the same number of shells. Alright. Now, the highest occupied energy level in the electronic configuration represents the period. If you want to use the period to do that, now look at magnesium. Magnesium has atomic number of 12. That is 282. 2 in the first shell. Okay, 2 in the first shell, 8 in the next one, and 2 in the next one. That is. Now, if you check how many shells do we have here, this shell 1, shell 2, shell 3. So this is in period 3. But if you look at the electronic configuration, 1s2, 2s2, 2p6, 3s2. If you don't know how to write this, I taught this in the last video. So please go back and watch. Now, if you look at this, the highest energy level here is 3s2. So it means this is 3s. It means this element falls in period 3 also. Alright, so that's that about the period. Take note, it is very important that what determines the period, elements in the period, is the number of shells. Now, coming to the groups, remember, groups, are they vertical or horizontal? They are vertical, right? Group 1, group 2, like that. Now, there are 18 groups in the periodic table. Take note, because old classification, like old textbooks and old scheme, says there are 8, which is still correct. There are 8 groups, but take note now that the current scheme, we have 18 groups, and they are not different. They are not different. I will explain when I draw the periodic table. But in any exam, if you ask how many groups do we have, there are 18 groups, and I will explain why when we draw the periodic table. All right, so elements in the same group have the same valence electrons. Valence electrons are electrons in the outermost shell. What determines elements in a particular group is the number of valence electrons it has. It is the number of electrons it has in the outermost shell. Now, look at something like sodium. Still sodium. Sodium, we already know it's in period 3 because it has 3 shells. What group will sodium fall into? If you want to know the group, just check how many valence electrons are in the outermost shell. How many electrons are in the outermost shell? Now look at the outermost shell here. How many electrons are here? Just 1. So sodium is in group what? Group 1. because it has one valence electron. Look at aluminium. Aluminium is in period 3 because it has 3 shares. What will be the group for aluminium? Now you check how many valence electrons. 1, 2, 3. So it's in group what? It's in group 3 also. Period 3, group 3. If you look at this one, which one is this? Oxygen. Oxygen is in period 2 because it has 2 shares. Then what group is oxygen? Now you check the outermost electron. How many? 1, 2, 3, 4, 5, 6. Group 6, right? Good. Alright. Now, that's the arrangement there. Take note that group 1 elements are called alkali metals. Group 2 elements are called alkali earth metals. I've seen this in past questions a lot. Group 2 are alkali earth metals. Now group 17 or group 7. Now please take note, if you are saying group 7, you use Roman numerals. Group 7, group 17 is also group 7, which is VII. Halogens, they are the halogens or the salt formers. They form salts. This is where you have your chlorine, your bromine, your iodine. They are group 7 elements or group 17 elements. If you are using group 7, use the Roman numerals VII. Now group 18 are the noble gases or the group 8 elements VIII. So group 7 halogens or salt formers, group 18 or group 0 or group 8. They are the noble gases, or if you don't call them noble gases, you call them rare gases, like your neon, very stable, argon, stable. All right, now that being said, let's look at the blocks in the periodic table. Now elements are arranged in blocks based on their electronic configuration. Now we have the S block, we have the P block, D block, and F block. In the last video, I talked about subshares. We look at the share K, L, M, N, like that, and we look at subshares S, P, D, F. Now, based on the electronic configuration, we can group elements into blocks. S block contains is made up of group 1 and group 2 on the periodic table, and their valence electrons, they contain elements that their valence electron falls in the S orbital. P block are groups 13 to 18. D block groups 3 to 12. They are all transition metals. While F block, they are the lanthanides and actinide series. They are those ones that are at the bottom of the periodic table. 15 lanthanides, 15 actinides. Alright, so that's that. Now we are going to look at the periodic table, and we are going to look at the periodic trends like electronegativity, ionic radius, and the rest. So I'm going to clean this, we'll draw the periodic table, and we'll explain in details. Now we are going to look at periodic trends. But before we look at periodic trends, which is a core exam area, let's look at this rough sketch of the periodic table. Now, if you look at this very well, this is not the complete periodic table. I just took an excerpt so I can use it to explain. Now, this is group 1. This is group 2. Now, this group 13, 14, 15, 16, 17, 18. Now, in another classification, which uses the Roman numerals, this is group 1, which is I. This is group 2, II. Group 3, III. 4, IV, V, VI, VII, VIII. That is 8, group 8. Now, if you notice here, we now have IIIB, IVB, VB, like that. If you look at this side, this side is omitted if you're classifying elements. If you're numbering it 1, 2, 3, you see you did not number this side. So if you're numbering it 1, 2, 3, 4, please use Roman numerals I, II, and A is used to designate the difference between this side and this other side. All right, now if you look at this very well, if you look at this element, hydrogen, lithium, sodium, potassium, now they are all in group 1. Hydrogen is placed in group 1 for convenience. Remember that what determines the group of an element is the number of valence electrons, right? And if you look at hydrogen, hydrogen has 1 valence electron. Good, it fits into group 1, but Remember, group 1 elements are metals, right? Group 2 are alkaline earth metals. Now, group 1 elements are metals, but hydrogen is not a metal, but it's placed in group 1 because of the valence electron it has. And lithium has one valence electron. That is why it's also placed in group 1. If you look at lithium with atomic number of 3, one valence electron. Sodium, one valence electron. Now, if you look at, let me just sodium to use it to explain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, this is hydrogen, this is lithium, this is sodium. If you look at them, they all have one valence electron. That is why they are in group 1. Remember, group is vertical column. Now, hydrogen is placed in period 1. This period 2, period 3, period 4. We have to period 7 before the lanthanide and the actinide series. Now, this hydrogen is placed in period 1 because it has one share. Look at it. Remember, what determines the period is the share. Lithium is placed in period 2 because it has 2 shares. That's why it's in period 2. Sodium is placed in period 3 because it has 3 shares. So you've seen it now that what determines the period is the number of shares, and what determines the group is the number of valence electrons, the number of electrons in the outermost share. The outermost share is called the valence share. Now, after this whole elements here, we have the lanthanide series and the actinide series that fill the f orbital. So here we have 15 elements here, 15 elements here. Remember, we have 118 known elements that fits into this periodic table. Now let's look at periodic trend. Remember the periodic law that when elements are arranged according to increasing atomic number, that there is an observed reoccurrence in their chemical or physical property. Now, the periodic trends, we have electronegativity. I'll beg you to pay great attention here. Electronegativity. Now, electronegativity is the ability of an atom to attract electrons in a bond. The ability of an atom to attract electrons in a bond. Now, look at this. I'll take 2 elements. This is sodium, and let me take another element, chlorine. Chlorine has atomic number of 17. This is the share configuration. This is the share configuration. 17. Good. Now, remember the octet rule. Remember the octet rule that says that elements tend to have a stable configuration of 8 electrons in the outermost share. So the outermost share, except hydrogen, the outermost share of atoms tends to be what? 8. Helium is 2, already balanced, noble gas. But that's duplex configuration. Now, other ones tend to have 8 in the outermost share, meaning that if this outermost share, which is the valence share, is not up to 8, then it is not stable. It will be moving around, trying to be balanced, trying to be stable, right? So now, what determines the reactivity is actually this number of valence electrons. Now, if you look at this is sodium and this is chlorine. Chlorine has how many valence electrons? 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. And remember the octet rule. It's supposed to have how many? It's supposed to have 8, right? For it to be stable. Meaning chlorine is not stable. It needs 1 more electrons to balance it so it's be stable, right? So what chlorine will do is chlorine will move around looking for where to get 1 electron from. Now, the ability of chlorine to gain 1 more electron, to attract electron, is called electronegativity, right? So among sodium and chlorine, which one is electronegative? Sodium has 1 in the outermost share, right? Will it be easy for sodium to receive more 7 to make it octet, or to give out this 1 and relax? You agree with me that it will be very easy for sodium to just give out this 1 and relax than to beg more 7 electrons, right? So sodium giving out 1, that is not electronegativity, it's electropositivity, right? Good. But chlorine receiving 1, attracting 1, that is electronegativity. So electronegativity is actually ability of an atom to attract electrons in a bond, and it increases across a period and decreases down a group. Let's check that. We say it increases across a period. Let's see how electronegativity increases across a period. Now look at this. This is a lithium, beryllium. This is across the period, right? So let me use lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Let me use the first one here and the last one here to see if it's increasing across the period or decreasing. Now lithium is okay, this is lithium here. It has 1 in the outermost shell. And fluorine, what's the atomic number of fluorine? 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 7 in the outermost shell, remaining 1 to complete it. Among lithium that has 1 in the outermost shell that can easily give it out, and fluorine that has 7, which one is more electronegative? You agree with me that this one will drag more electron than this one that can easily give out 1. So you can see that it increases across the period and decreases down the group. Electronegativity decreases down the group. Why is it decreasing down the group? Electronegativity decreases down the group because you agree with me that as the group is going down, as you're going down the group, the number of shares are increasing. The number of shares are increasing. And the farther away the electron is from the nucleus, the more easily it can be given out. Instead of attracting. All right, that's that. Now, the most electronegative element, take note because it's an exam question. The most electronegative element is fluorine. Fluorine is the most electronegative element. All right. Ionization energy. Now, ionization energy is the energy needed to remove an electron from an atom. The energy needed to remove an electron from an atom is called ionization energy. Now look at this. This is the nucleus. This is the valence electron here, 1. The energy required to remove this electron from this atom is called ionization energy. Why is it called ionization energy? If you remove this 1 electron from sodium, it is no longer sodium atom, it's now an ion because it has given out. Now if it is giving out, it will acquire positive charge. It is better to give than to receive. So giving is positive, receiving is negative. Now if sodium gives out this 1 electron, it has acquired a positive charge, so it is now a cation. Why something like chlorine that will always receive 1 will be an anion. So please, you can take note of this plus here, this T here, to show you it's positive, cation. All right, so the one that receives becomes an anion, the one that gives is a cation. Now, the energy needed to remove an electron from an atom is called ionization energy. And now, let's see if it increases. We say it increases across a period and decreases down a group. Let's look at that. This is hydrogen, this is lithium, and this is sodium. They are all in group 1. They are all in group 1, but they are in different periods. Now, this is in period 1, period 2, period 3. Look at the nucleus as a magnet attracting electrons to itself. It means the closer this electron is to the nucleus, the more attracted it will be. The force will be very high. But if you are going far like this one now, this electron now in sodium here is a little far from the nucleus, so the force of attraction will be low, is it not? We said that ionization energy increases across a period, right? Ionization energy increases across a period. Now look at the period here. So from lithium to beryllium to boron, like that, ionization energy is increasing that way because the energy needed to remove a valence electron increases that way. Now it decreases down a group. Look at the groups now. Hydrogen, lithium, sodium, they are in group 1, right? They are in group 1. And since they are in group 1, if you look at this one has 1 share, this one has 2 shares, this one has 3 shares, and they're in group 1. I told you earlier on to look at this as a magnet. This one is farther from the nucleus, so the force required to remove this one will be lower than the force required to remove this one that is very close to the nucleus. Are you following? The force required to remove this one from the nucleus will be very low compared to, because the nucleus is acting like a magnet attracting electrons. This one is far from the magnet, so it will be very easy to remove it. So you can see that ionization energy decreases down a group because the shares are different. The next one is atomic radius. Atomic radius is the distance from nucleus to the outermost shell. The distance from the nucleus to the outermost shell is the atomic radius. So the distance from here to here, atomic radius. The distance from the nucleus here to this other one is the atomic radius. Distance from this one to this one is the atomic radius. So from the illustration so far, do you think it is increasing down the group or decreasing across the period? Well, it decreases across a period and increases down a group. How is it increasing down a group? These are group 1 elements: hydrogen, lithium, sodium. They are all group 1 elements, but this is in period 1, period 2, period 3. If you look at these elements in the same group, the number of shares are increasing. So since the number of shares are increasing, you discover that the radius, that is from here to here, is higher than from here to here. It's longer. This one is longer. Remember, atomic radius is distance from the nucleus to the outermost shell. So this one will be longer than this one, will be longer than this one. So you can see that atomic radius is increasing down a group and it decreases across a period, though they have the same number of shares, but electrons, the nucleus attract electrons to itself. So take note that it decreases across a period and increases down a group. The last one I'll talk about, I don't want to make this very long. The last one I'll talk about is electron affinity. Affinity is just like coming together, bringing them together. Electron affinity is the energy change when an atom gains an electron. Energy change when an atom gains an electron. Please don't confuse electron affinity with electronegativity. Electronegativity is the ability of an atom to attract electrons, while electron affinity is the energy change. So here we are talking about energy change when an atom gains an electron and it becomes more negative across a period, especially in halogens. So far we've looked at the periodic table. We've looked at the Mendeleev periodic table that was arranged based on relative atomic mass. We've looked at Henry Moseley periodic table arranged according to atomic number, which is the one we are still using today. And we've looked at any other things. If you have any question, please feel free to drop it in the comment section. And if not subscribed to my channel, click on the subscribe button. Like this video and share it. See you in our next video. My name is Excellence Simplified.